In most cases, phi x will be function of x, and f(x) may be constant or function of x. In such type, or for this special form of function, we have to use logarithmic differentiation. I advise my students to write the statement base e log y is equal to log x to the power x, that is equal to x log x. Next sum, y is equal to log of this, that is of the form function of function. Let y log u to the base 3, where u equal to x plus root over x square plus a square. Now I find there is root over x square plus a square. I first find the derivative of this one. Now ddx of root over x square plus a square, that can be written as ddx of x square plus a square to the power half. I take that v of v to the power half into dv dx, where v equal to x square plus a square. I have found the derivative of this one separately. Taken x square plus a square as v, then ddv v to the power half into dv dx, generally. That will be equal to half v to the power half minus 1, means minus half, into dv dx x square plus a square is a is constant, therefore ddx of x square, that will be equal to 2x. Put that value. V to the power minus half means root over v at the denominator, root over x square plus a square. Now y is equal to log of u to the base e, and u is equal to x plus under square root symbol x square plus a square. Therefore dy du of log u 1 by u, that is equal to 1 by x plus root over x square plus a square, and du dx is equal to ddx of x plus root over x square plus a square, that will be equal to ddx of x plus ddx of root over x square plus a square. Already we have got the derivative of this. Here I have found it will be equal to 1 plus x by root over x square. On simplification, it will be numerator x plus root over x square plus a square by root over x square plus a square. I write here, therefore dy dx, write the chain rule first, dy du into du dx, put values 1 by x plus root over x square plus a square into x plus root over x square plus a square by root over x square plus a square. Therefore, finally, dy dx is equal to 1 by root over x square plus a square. Here, these two expressions cancel from numerator and denominator. Finally, we get dy dx. Thus, I have worked out here few interesting sums and tried to make you understand how to handle chain rule rather. Thus, first rule, chain rule, has been discussed. Now, second rule, logarithmic differentiation. From the name, it is clear that we have to use the concept of logarithm. Actually, this is specially applied for a special type of function. The form of the function will be y is equal to fx whole to the power phi x. Here we find fx phi x. In most cases, phi x will be function of x and fx may be constant or function of x. In such type or for this special form of function, we have to use logarithmic differentiation. First of all, we have to take log of both sides to the base e. After that, we have to progress like this. Therefore, log of y to the base e is equal to log of power form. Therefore, it will be ix log of fx power is taken in front, then log of this. Log y to the base e is equal to phi x log of base is of course e. Thus, after taking logarithm of both sides, we get this one. Now, we differentiate both sides with respect to x. Students, you note with respect to that is written in short form W full stop R full stop T full stop. Now we find left side is function of y. Actually, I will write this step first. Now we find on the left side derivative of log y with respect to x. That is not possible directly. Here we have to use the chain rule. That means we have to differentiate it as it is function of y with respect to y first, or dy of log y into dy dx, and on the right we get form u into v, product form. Therefore, I shall use ddx of uv, that is equal to u dv dx plus v dv dx. Phi x into ddx of log of fx this one plus log of fx into ddx of phi x. Now we calculate this phi x. Now this is function of function form, log of function fx. If I consider fx as u, I do it mentally. I also suggest you will do mentally. Log u equal to fx. That means first you differentiate log u with respect to u, you get 1 by u, that means 1 by fx into ddx of u, that means ddx of fx. Students, you note carefully, I have done mentally this step. Let me clarify again. I first take log u, fx as u, then log u, that is to be differentiated with respect to u, so that it will be 1 by u, that means 1 by fx. Then into derivative of u with respect to x, that means du dx. ddx of u means fx, I have written this, plus log of fx into derivative of phi x with respect to x, that is represented by this phi dash x. Therefore, this is phi x by fx into f dash x plus phi dash x into log of here I have taken phi dash x first. Actually, while you are working out, you may be confused. Log of whole, not that. That is why I have written phi dash x first. Therefore, this one will be 1 by y into dy dx. Therefore, finally, dy dx is equal to y into the whole, means pi x f dash x by fx plus I dash x into log of fx. You see, I have used ln. Already I have discussed earlier, when log base will be e, that means natural logarithm. In place of log base e, we use the symbol ln. Now you can replace y if it is required, otherwise you keep this in this form. Now I take few examples to clarify the method. First of all, x to the power x. Here we see base is variable, also power is variable. We first take x to the power x equal to y. First you carefully see whether power is mere number or function. When you see the power is function of x, then we must apply logarithmic differentiation. Taking log of both sides, I advise my students to write the statement base e log y is equal to log x to the power x, that is equal to x log x. Log y is equal to x log x. Then differentiating with respect to x, ddx log y is equal to ddx x log x. I advise my students, when you are learning, you follow these steps which I am following. Differentiating with respect to x, it is function of y. I suggest to follow this. ddx of log y equal to ddx of this. Now this is function of y, or ddy, we are using chain rule, into dy dx is equal to, now u into v form, x log x, product of two functions of x into derivative of log x plus log x derivative of x, form u dv dx plus v du dx. dy of log y means 1 by y into dy dx is equal to x into 1 by x plus log x into 1. If we simplify, we get 1 plus log x. Therefore, dy dx is equal to y into 1 plus log x. Now here y is not so complicated, large expression, we put the value. Learners, you follow the steps which I am working out. First, you note the given function. If you find the index or power or exponent is function, then you are to apply logarithmic differentiation. Now, these are the steps. Also, in this case, we can follow this method also. Y is equal to x to the power x. That can be written as e to the power x log x. While the given function is in short form, not so complicated, we can apply this method also. Now this is of the form e to the power u. We can apply here chain rule. Let y equal to e to the power u, where u equal to x log x. Then this is from this dy du e to the power u means e to the power x log x, that is equal to x to the power x, and from here du dx is equal to ddx x log x, that is equal to x u into v form, u into derivative of log x. Better I write this form, plus log x ddx of x, that is equal to x into 1 by x plus log x into 1 plus log x. Therefore, from here dy dx equal to dy du into du dx. Chain rule applied. Put the values. Dy du x to the power x into 1 plus log x. Here I have used function of function form, and here logarithmic differentiation. In case of very short form, not complicated, we can use this method also. Next example. We have to find the derivative of this with respect to x at x equal to pi by 4. We start like this. Let y equal to we see base exponent both are function of x. Therefore, logarithmic differentiation, we take log first. Differentiating I always suggest my students you use these statements. Now I skip the step. Log of y, we are differentiating with respect to x. Therefore, in this step, we have to use chain rule. I write directly derivative of this with respect to y, that is 1 by y into dy dx. Then on the right side, sin x into ddx of log tan x plus log tan x into ddx sin x. I first simplify this one, sin x, then ddx of log tan x, that is again function of function form. I consider tan x as u, that means log u, that is to be differentiated first with respect to u, that will give you 1 by u, that means 1 by tan x into ddx of tan x, ddx of u. Finally, sin x into sec square x plus cos x into log of tan x. Now these sin x are cancelled. Here, remember, sin x is non-zero. Then cos x into sec square x means sec x plus cos x into log tan x. I write this one here, 1 by y. Therefore, dy dx is equal to y sec x plus cos x into log of tan x. Dy dx is equal to, in place of y, we put this value within brackets, this large expression Therefore, finally, dy dx at the point x equal to 4. Sorry, x equal to pi by 4. We put x equal to pi by 4. 10 pi by 4 means 1. To the power anything, that will be 1. Therefore, this is 1. Then within brackets sec pi by 4 means root 2 plus cos pi by 4 1 by root 2 log of 10 pi by 4 means log of 1, that is 0. Finally root 2. Therefore dy dx at x equal to pi by 4, that is equal to root 2. I want to mention here, students, while you are working out this one, first you have to calculate dy dx correctly up to this. Then marks will be awarded for that part. Actually, for this last part, few marks, say out of 4, you will be awarded 1 mark only. Therefore, this initial part is very important. You have to work out up to this correctly. The sum is finished.